Welcome to P.7, Day 2. In this section, we're going to be adding and subtracting rationals. This is a little bit different than adding and multiplying and dividing because you're going to need a common denominator. So we'll talk about that in this one. But first, you're going to do your warm-up. So again, pause the video, do your warm-up. Okay. So now, sorry, this is a little typo there. It should say completely. Go ahead and factor those. You should have a difference of squares here. And this is a sum of cubes. And this one is just a normal quadratic. Okay, so adding and subtracting rational expressions. So let's review when we add and subtract fractions, okay? So 1/2 plus 2/5. I don't just get 3/10, okay, or 3/7. I don't just add 1 plus 2 and 2 plus 5. You have to have the same denominator. So you learned this back in elementary school. To find the same denominator, you find the least common multiple of those numbers. So that will be your least common denominator. For 2 and 5, your least common denominator is 10. So my LCD is 10. And in order to make 2 a 10, I'm going to have to multiply by 5. Okay, but I can't just multiply the bottom by 5 because that's changing the value of that fraction. So I have to multiply by 5 over 5. 5 divided by 5 is just 1, so I'm multiplying 1/2 by 1. I'm not changing the value of 1/2. So then to get 2/5 to have the same denominator, we're going to multiply by 2 over 2. So this would give us 5 over 10, which is 1/2, and 4 over 10, which is 2/5. They just are with the same denominator now, so I can keep the same denominator on the bottom, 10, and I add across the top. So the reason I show you that example is because we're going to be doing the same thing with polynomials in our numerators and denominators. So the second example here, when the denominator is already the same, so that factor, we have a x plus 5 and an x plus 5, then when I subtract in this case, I keep the x plus 5 on the bottom, and then I just subtract on the top. And we combine any like terms. There are no like terms, so then this is my final answer. That's my expression. Okay, so when the denominators are not the same, you have to find a least common denominator. So now we're going to practice finding that LCD. So this section, this can sometimes be difficult to grasp what that is. And if you don't really think you got it in the spring, make sure you come and ask me because this is something that can be a struggle sometimes. So just make sure you email, ask, come to a Google Meet. Okay, so we're going to find the LCD of these two expressions. So here's our first example, 16y and 2y squared. First thing you want to do is factor. Well, there's not really anything to factor here. So if it's like 2y squared plus 4, then I could factor out a 2, okay? So we want to look at each component. So first we look at the numbers. We want to find the least common multiple of 2 and 16. Well, if I think about the multiples of 2 and 16, listing out my multiples 2, 4, 6, 8, we get to 16. We'll notice that 2, a multiple of 2 is 16. So my least common multiple of those two numbers is 16. Okay, so 16 is going to be part of my denominator. And then I need to account for the y. In this one, I have a y. In this one, I have y squared. Okay, so I need to account for every part in my denominator. So I need the y squared. Y squared is just y times y. Okay, so this y is taken care of in that y squared. It's like if you think about if I had a 2 and a 2 times 2, or a 4. Okay, my least common multiple is 4. I don't also have another 2. That would make my least common multiple 8, and that's not the smallest number between 2 and 4. Okay, if that's still confusing, just bear with me and see if it starts to get a little bit easier. But this is the LCD, okay, of those two expressions. Everything in both expressions is represented. Okay, so now I'm going to look at these two. They're already factored, okay? So again, this expression, everything, every part has to be represented. So in my LCD, I need to have an x minus 3. Okay, I also need an x plus 5. Okay, now I go over here. Do I have an x? No, these are x minus 3 and x plus 5. I don't have an x yet. Do I already have an x plus 5 represented? Yes. I don't need another one because if you think about if I had an LCD and one was 2x and the other one, or two expressions, one was 2y. Okay, the 2 is represented, so I wouldn't need to multiply the 2 by anything. Okay, because the 2 and the 2, they match. So I need just one of them in my least common denominator. So this would be my least common denominator. Everything has to be represented. So the x minus 3 is represented, the x plus 5 is represented, and the x is represented. Okay, let's look at an example to see if that helps a little bit. If you're still struggling, remember, ask questions. Okay, so when we're adding and subtracting rational expression, the first thing you have to do is find the LCD. Okay, that's what we were just practicing. Factor the denominators, find your LCD. Then, if we think back to what we did over here, once we knew what our LCD was, we had to multiply by 1, essentially. And our form of 1 here was 5 over 5. That was what was missing from the denominator to make it 10. So I needed to multiply it by 5. And then we simplify. So we'll look at those steps here in a minute, add and subtract. We'll look at that. That's just a reference to go back to. Okay, so if you notice, 16y and 2y squared, we actually did that here, 16y and 2y squared in that first example. So my LCD is 16y squared. Okay, so then I want to multiply by factors of 1. So I want to multiply each fraction by what's missing. So in my LCD, I have a 16y squared. Okay, I have a 16 here, I have a y, but I need another y. So I'm going to multiply by y over y. And then on this one, I have a y squared and I have a 2, but I need that to be a 16. So what's missing from that is an 8, because 2 times 8 is 16. So I'm going to multiply the top and the bottom by 8, multiplying what's missing so that I can get the denominators to be the same. So this one is 15y over 16y squared. And then this one is 56 over 16y squared. So do we see how that LCD, we found what the LCD needed to be, so that would be how we'd get them to be the same, okay? That's the least common denominator that we have, so that these would be the same. We multiply by what's missing, now these are the same, and I can just subtract my numerators. So on this one, I have 15y minus 56 over 16y squared. Okay, so that's the add or subtract the numerators. And then this is my final answer. if there's nothing else to factor and cancel. So what I would traditionally do, in this case there's nothing really to factor, but you want to look at the numerator and see if there's anything that could factor and cancel with the denominator. And then you would do that if it's possible. And then we're going to write our disclaimer. So y cannot equal, and in our denominator it cannot equal 0. That's the factor. So this is my final answer. Okay, so now we're just going to do some more practice problems. So each of these I would practice on your own first, and then come back and watch the video. So I'm actually going to stop the video here so that you can take some time to practice, and then I'll make another video with all of them worked out and finishing those notes.